Hello! Something very different today, and I say I'm often looking at something different. This just looks like a jar of stuff. It's in fact a sensor prototyping kit made by Seed Studio. That's Seed with 3 E's, of course. And yeah, it's a bit of a strange bit of packaging. Inside of here, and we'll take you to close up later, you can just see like a bunch of boards and stuff. What is this? What am I talking about? This sensor kit from Seed has a bunch of different sensors, and most excitingly in this kit there is this thing called the Groove Vision AI module, which is this little camera and board. It's called Groove because that's the connection method they use for doing stuff, and you can basically train it to recognize things. And I thought, well, this is interesting. I've never really messed with AI or machine learning, so I thought that's something I'd like to play with. But I'm just thinking this is something that could potentially not just be about like prototyping electronics, but could go on a flying thing to spot the number of sheep in a field or the number of people walking around. You know, I don't know how good this is, but this is the sort of thing I was kind of thinking of. One of the other things it's got in it for basically talking to the outside world is this LoRa module. And if you're coming here from the RC perspective, you might notice that, as LoRa modulation is something that's used in many of the big RC links at the moment. Express RS, Crossfire, all are LoRa based things. So good range, low latency. I mean, I'm simplifying it mostly because I don't know myself, but it's all in this little box. Why don't we get a close up? We'll take it out and we'll see what we can do. Quite complicated in terms that there's lots of things here, but Seed supply a lot of test code and example use cases and stuff. So let's go to close up, let's see what's in there, and let's get programming and see what we can do with it. Okay, here's our sensor prototype kit. Let's see what's in there. We have a big stack of stuff. It's cables, and let's just empty the whole thing out, I think is the easiest way of doing it, and let's see what we've got. So there's a couple of recognisable things. First is this one. This is the YO terminal. I reviewed one of these before, and I did a little basic project so I could check if my little GPS was working and stuff like that. There'll be a video link to this. This is going to be our base station for testing this stuff working. We've got a little USB to USB-C cable. Focus, there we go. We've got various connectors. I think these are the Groove connectors. These ones down here are the Groove interfaces, and they're peculiar. So I think they mostly run on 3.3 volts instead of 5. So they're a little different there. So that's those, and you've got one with these little things where you can just poke into something. These are the sensors it comes with. So this is the exciting one. This is the Groove AI Vision. So you see you've got this little camera here, a USB interface. You've got your Groove connector to hook it up. Looking forward to understanding what that's all about. I think that's certainly the most exciting thing in here. This is a gas sensor, apparently, which must be this sensory thing there. That'd be kind of interesting to find out how that works. This is a moisture sensor. I think the idea is this maybe use it in plants, so shove it in the soil, check your plants got enough water, and sort of report back if there's a problem. This one's a temperature and humidity sensor. Again, in combination with other stuff, this will give you some interesting data. This is the LoRa module that can actually send that data to somewhere. I think they talk about using some sort of LoRa cloud network or something. I don't know if that's our only option, but we will see. Yeah, anyway, we've basically got these bits to play with somehow. But what I'm going to do now is going to take a look at some of that documentation they include, look at some of their demo and example projects, see how they work, and then think about what I can do to have some fun with this and see its potential. So let's do that next. Now, part of looking at something like this, where it's not for a specific purpose, it's kind of built for you to experiment with, it's hard to talk about all the very many things it can do. Each of the individual sensors can be coded individually and stuff, and you can use them for all sorts. But there is this handy little application called SenseGraph, which is a really nice piece of code, actually, looking at how the GUI works and stuff, where you can basically play with all the bits. What I've got plugged in here is the LoRa module, and these are what's happening to its internal sensors. We've got the sound, we've got the light, we've got the IMU. The light sensor's at the back, so if I cover it up, you'll see it go down. I can bring it back up again. We can press the button, and then we get a sort of a rolling thing of what's happening. Like I said, a really nice piece of code, this one. And what it will allow us to do is basically plug something in. Like this is the soil sensor, or soil moisture sensor I should say. If I plug this guy in here, it detects its soil, and if I just put my hands on that, it goes up a bit. If I give my fingers a quick lick and then do it, it goes up higher. It's not really giving me any instance of what the scale means. That's kind of up to you to do, and your sort of potential application there would be obviously to stick this in a plant and have it monitor. And I'll talk about kind of what might be the hardware setup for that, because it wouldn't be this, because it would run out of battery a bit quick. But we'll talk about that when I talk about the LoRa module. But I just thought I'd take you through the things. So that's the soil sensor. So let's plug in the temperature sensor. Temperature and relative humidity is what it senses. Oh, I've just pressed the button accidentally. And then we've got a temperature of 22.9, humidity of 61. So I should be able to affect that if I just put my finger on it. So I should be sort of 37 odd, and you can see the temperature's slowly going up. What I'm going to do is just going to breathe on it to bring the humidity up. At the moment, humidity is sitting at 80. That went up a little bit, 85, 89. Yeah, that made it a bit more humid. So that's that one. This is the CO2 and VOC sensor. Honestly, I'm not quite sure how to read this. 400 parts per million of CO2. Maybe it's just not finding anything in the atmosphere. And finally we got the vision sensor module. And this one works slightly differently. It's basically saying it's got a vision count. 1/100. What it's basically doing is counting the number of humans and its percentage, how clear it is. If we go to processing, we can do vision analysis here. You can see what it's doing. But it's not particularly useful because we can't really see what it's seeing, which would be more useful, I feel. But let's come on to these and how we use them. But first I want to talk about this guy here, the LoRa module. Now if you look up here, if we press this button, there is an uplink, so we can basically send all this up a LoRa network, and you see you've got various things to do here, and you can program it to do that, or you can use Wi-Fi on this as well, and that's pretty easily done. You just have to change the text file and it will just load onto Wi-Fi. And this is where we come into how this works and the type of cloud networks you got, which is kind of a big subject, but let me try and go through them a little bit and tell you what sort of things I found and what I've played with so far.
Now, I've actually had this kit for quite a while now, and I've kind of struggled to know what sort of video to create because the scope is so large. Part of the reason for that is this, the LoRa module, and I learned a lot of stuff about what this is and what it can do. For instance, I didn't know there was this whole network of LoRa capable devices called LoRaWAN, I think, the LoRaNet, can't remember now. It's called something like that. And in my country, in the UK, it works on 868 megahertz network, just like Crossfire or other control links. And there are gateways that you can send messages to and upload data to the cloud that way. And these aren't networks in a traditional sense. They're not there to send like huge amounts of data and replace Wi-Fi. The idea of these is they can send small payloads over big distances with relatively small power consumption. And to do that, you then need to obviously get to a LoRa gateway and send it up to something. And there are a bunch of cloud services to do that. And whenever you talk about cloud services, each one has their own massive set of things to talk about, like costs and rules and what you can send and then how you can access the data. So a typical use case for this sort of thing, and in this we're talking, this is for like prototyping. If we were to have a commercial product
then we'd have perhaps the prongs of the sensor for the soil, and then the rest of this would be sort of fully enclosed. And what it might do is send data like every hour to a LoRaWAN gateway, and that will go up on the cloud, and then you might have some sort of smartphone app that you could then access that data, and it could send you alerts, for example, if your plant was drying out or something. And using this sort of low power, low latency, big distance network, if it's working correctly, you can power something on a relatively small battery for years and just leave it in place. But to do this, it means you have to talk about cloud providers, and there are many, and I've experimented with quite a lot of them. The biggest one's called Helium, in terms of the LoRaWAN, and that's probably because it's some sort of crypto thing where if people set up gateways, basically they can mine it and earn currency. So there are more gateways about there than anywhere else within my local area. The closest one's about a mile away, and I've got some footage here of me sending sort of data to it, and I'm just sending the light data. And I'm getting an error here. I'm able to connect to it, I'm not able to deploy my payload of all of 2 bytes. But it did work previously. Perhaps the atmospherics are not great today and it has to go through loads of buildings and stuff. But Helium has a lot of gateways, but it only gives you 250 data packets to start with until you have to pay. So that means unless you really want to do this, I mean, it's not expensive, but unless you really want to do this, it's not something to experiment with. There's also a service called the Things Network, which is similar, but there's not quite so many gateways. I couldn't connect to that one either. Seed have their own SenseCap network. Again, I couldn't connect to a gateway to do it. But alternatively, you can come in via Wi-Fi, and if I connect to Wi-Fi, one thing I tried using was Azure, which is a Microsoft thing. It is a paid-for service, but if you join, then Microsoft gives you like $200 worth of credits for nothing, and most of the services you can test with are free. But that's kind of your workflow you might be looking at if you wanted to prototype something that you then manufacture later. It's kind of like update to LoRa via a cloud service, access that cloud data via a phone app or a web app or something like that, and get that to your users. Now, when I looked at a commercial version of this, I just had a quick look and found one at Amazon. I did notice that instead of sending over LoRaNet, they were coupling their soil sensor with their own 868 to Wi-Fi gateway themselves. So you'd have something in the garden perhaps which would send into your house over 868, and then it will upload the data to their own service or your server or whatever via normal Wi-Fi. But that's kind of the gist to it. I will not dwell on this because it's a lot, and there's a lot to mess around with and stuff. Just imagine that anything you can do with this sense data, you can upload via Wi-Fi to a cloud service or via LoRaWAN to a cloud service if you're in touch with one. Alternatively, you can use all that sense data and display it on your own screen, using the wired terminal, using something else. It's up to you. You can send it to your own server if you want to and monitor stuff that way. And you will find decent example code on each one of these sensors about how you can simply interact with it, get the data back and display it in whatever way you want. That bit's up to you. But what I thought I'd do with the rest of this video is maybe have a look at this, the Groove AI sensor, and see how it works and see how we can get it to look at video, extrapolate data from it using AI training and see what we can get to. So let's try.
So I'm just filming with my phone here, and I'm using the inbuilt app which is already trained to look for human faces, and it says it's finding me. Sometimes it's finding two of me, a confidence of 70-ish%. If I look at what we're doing, I've got the camera up here. You'll notice it's a very narrow angle, and on the screen here, let me try and zoom in. That's me in a window, and it's drawing a sort of square around me saying, oh, I think this is human. We're sort of 70% sure. And you'll notice the window is very small. This camera can actually produce images something like 1600 by 1200 pixels, but because the data transfer rate is a bit slow, it's doing a small window of 192 pixels, which is why I look a bit pixely. And so what we've got is we've got USB to power the YO console. We've got the Groove connector into the camera along with its own USB-C, and then up here we're running this SenseCap AI Vision. It's a site, look at me zoomed in, which runs a bunch of JavaScript basically to talk back via USB to get the still image and put it up there. You can see it's a bit slow. We're getting one image every couple of seconds or so here, so it's not like live video or anything, but it at least gives us an idea that we're doing the right thing. But so that seems to work okay-ish. What I want to do is try and train it to do something else, and I thought I've got a cat. Let's see if it can recognize a cat. I think you can actually install 3 training programs on it, so you can have it look for multiple things at the same time. But yeah, let's see how the training works and get it to do something else. So as far as training and deploying your own AI model into the Groove Vision AI, it uses a thing called TinyML, which is this interfacing model. It's not really important to know that much about it. That's the good news, and there's various ways of doing it. So the sort of most obvious way, if you like, and I'm scrolling through here quite quickly, is you can literally change the firmware on the camera, get it to take loads of photos, and then you can go into some other software and build yourself a data set, and you're literally drawing rectangles around something to say this is an apple, these are apples. And after you do that in a couple of hundred images, it can link some stuff together. What I'm going to do is use sort of pre-annotated data sets, and they're available from this website called RoboFlow, which looks like this. So I can go into here and I want to search for cats. So if I say show me some cats, it will come out with some cats and tell you the amount of images we've got here. Even cats vomiting, which is always useful to know. So I see this one here is called Cats Big. It's got 11,442 images, which is a lot of images, and I'm thinking, that's going to be really good. So let's go ahead and download this data set to start with. Now this is where it's a little bit different here. Basically you want to say show the download code, and this is all talked about in the reference for how to do this. And the reason that some of this needs to be kept sort of secret, if you like, is there's an API key which links specifically to your user on RoboFlow. So if this was anything that was, any sort of private data or anything, and you didn't want to share it, then don't share that code. What I'm going to do is click on this link, which opens up a Google Colab space. And this will basically talk you through how to basically process this thing. And this is the first time I've seen Google Colab, and I have done one before as a test. But anyway, what you do with this thing is you make sure that the runtime type is set to hardware accelerator for CPU, which it is. And then you can go ahead and run one of these. So we're doing a git clone to get ourselves some workspace. We're setting up our environment, and this is where we're doing the cut and paste, and this is kind of the secret bit, if you like. So we basically go ahead and paste this into here and see if that one works. Okay, so this is doing the download, which is surprisingly big. Right, once we've got that, we're doing something in this step, nothing particularly exciting there. We're downloading the pre-trained model, which we're going to use to train with that training data. And this is the biggie. This is the actual thing that goes ahead and does the training. And this will do these 99 iterations of all the training. It comes up and it will say, well, once we get there, I see it runs for what it calls 100 epochs, which is an interesting name. And this is running on the GPU, so it's trying to take as much advantage of the fast maths that the GPU can do. But each run of the epoch takes a fair old amount of time, and we're going to run this basically 100 times. So we're probably looking at somewhere in the region of, let's have a look. So that's about 40 minutes, 45 minutes perhaps. It's a fair old amount. So I'm just going to leave this here for now, and we'll come back when that's finished. Okay, so an hour has passed, and one thing you need to do is get here within a certain amount of time, else it just disconnects you and you have to run the entire thing again. And should you run out of the GPU that it will give you, you have to run it on CPU, and that takes about 6 hours. So try and do the best you can. So we're just doing the next thing, exporting the results file, and then we converted this thing called a UF2 file, which we actually put on the Groove AI sensor, and you can actually have up to 4 models, but you can only use one at once. So we'll do this one with the index of 1, perhaps we'll do another one afterwards. So we just run that. It doesn't take long, and finally we can go ahead and download it, and there we go. So once we have our training models ready, we go ahead and we plug the Groove AI camera into USB, and we double click the boot button. This will make it go into mass USB storage, and you see over here we've got this Groove AI. That is basically the disk for it, and what I'm going to do for each of these models, I'm going to drag it in to there. And what will happen is after it copies it, it will basically unmount itself, and then we have to go back into boot mode. And then I'm going to basically repeat that with the others. What I did after I did the cats, I did model number 2 was on drones, which took quite a while because there were a lot of different pictures there. And then because I ran out of ideas, model 3 is trained to recognize bananas, which there wasn't very many pictures based on because, well, they're bananas, and that didn't take very long at all. So it just depends how complicated your data set is about how long this will actually take. So I'm just going to go ahead and put these other 2 on the device. You won't see the previous ones there, they'd have disappeared, and then we'll try and test them out. So Seed gives some example code here in part of their Arduino Groove AI library, and this one's called Object Detection. It just basically has the very basics of how you would get this to work, and it's all this AI begin thing. And what I'm going to do, because I haven't got any cats around me at the moment, but I have got a load of drones, is change the index to number 2, because this is the model we're going to use, and I'm going to say number of drones here, I guess. And then I'm going to just plug in my YO terminal, and let's upload that, and then we can connect everything in. Just make sure this connects and compiles okay. Yep, okay, let's plug in the rest of the stuff and we'll see if this works. Okay, so to explain what's going on here, I've gone ahead and I've made my basic code using model index 1, which is the cats, and I've got the camera pointed at my screen. I've got some Google images up here of cats, and this is the output to see if it recognizes them, and it's a bit hit and miss, I have to admit. It's not too super confident. If I go on to the next one, sometimes it gets them, and sometimes it's like, nah, that's not a cat. I guess it's all about how good the training images are and how well these come up. I mean, it's getting this one here. Oh, now it's got that one there. It sort of thinks about it for a bit. Now it's interesting. The angle of the camera seems very crucial as well. Like if it's slightly off, perhaps it's picking something up from the screen that's not getting it. But I'm getting more misses than hits on this one. And when it seems to detect it, it often seems to detect sort of bits of fur than the actual sort of cat itself. You know, I tend to think cats is pretty recognisable in terms of their eyes and ears and things, but it always seems to draw a box round sort of the bit you don't think about, like I didn't get that one. And I did have real problems getting this running at first. It seemed like the data set just wouldn't run up properly, and I ended up sort of writing it multiple times to the YO, and that was fine. It is like 81% confident that this one here is a cat, but it's not identifying this one. And if I then clicked on that, it's almost like the big image it can't take in as well as the smaller image. I wonder if that's part of it. And sometimes it seems to sort of come on and back and stuff, and it'll say that's a cat, and then that suddenly it's not a cat. Now I've checked it against stuff like dogs, and the good news is it normally doesn't detect dogs either, except when it does, which is sometimes. That the pug's apparently a cat. It's like strong hit on a cat. Well, I mean 53%. I suppose it's not bad. I'm trying to think like what is it in a pug that it's like this is very dog-like. And I think this little guy got detected previously. Yeah, it's just a little bit hit and miss there. Detect the cat. It's a cat. Okay, I've now set it to bananas, and at least it doesn't think that cats are bananas. What about dogs? Are dogs bananas? No, it says. What about bananas? Are bananas bananas? Find me a single banana image. There is a banana. It doesn't recognise bananas as bananas. Okay, well I think we should try drones, because drones had the biggest data set. Oh, now you think it's a banana. It's a bit late now, unless the order's been mucked up here. So now you think that's banana even though I think I'm doing drones. Interesting. Alright, give me another banana image. It feels like we've mixed up bananas and drones somehow here. I don't quite know how. Now, just to double check, this is definitely bananas. If I show you a picture of a drone or a cat, you don't think that's it. But if I show you bananas, okay. I was quick to jump to conclusions there. It's actually quite good at identifying bananas. What I don't understand is how my file naming is incorrect there. That's a bit weird, because this is definitely pretty good at detecting bananas as it happens. Literally, put any bananas there, it's like, yeah, I'm pretty happy that's a banana. That's a banana. We've certainly settled on a strength here. Bananas are pretty simple shape, and it's always generally this very interesting colour. So where's my drone set gone then? Let me try setting it to index 4, which I didn't actually put them on, but see what happens. Okay, so we got no identification. What about a drone? I think I found the drone set. So in between doing all of this, I tried uploading another model which I think was humans, but that didn't have a number with it, and perhaps it's the order where it goes on is the significant part. So okay, you think that's a drone. What about that? Also a drone. And what about this? Definitely a drone. What about a banana? Banana's not a drone. What about a cat? Oh, it's still pretty happy that a cat is a drone. So this is my confusion point. It's like, well, what's it identifying here? Here's some more cats. It's not so confident on those ones. Well, it looks like it was trying to get that. Have I misidentified my data sets completely here? Because it seems pretty good at identifying drones here. Yeah, that's actually pretty good, isn't it? The data set on the drones was very large. It was like 11,000 images or something. And it seems to be doing a pretty damn good job, actually. I'm doing all sorts of distant drones and saying, yep, that's a drone, that's a drone. Ooh, this one's a bit low contrast. It can't detect the whites very well from that. But yeah, it gets that one. Even gets that one up there, that little tiny thing. About that, yeah, that's one. That's one. Okay, so I'm definitely happy that I've got the right data set here, and I'm going to try pointing it at actual drones that I have hung up to see what we get. That's my wall where it's like, yeah, that's a drone. Let's find another one. I'm reversed in the camera. Just about got it to identify two at once. So I really do think the quality and the size of the data set seems to have an awful lot of say into exactly how well this thing's going to do. This was a large data set, and obviously had a lot of pictures of a lot of different types of drones from lots of different angles, because it's really doing very well in this. On the other ones, I'm not even sure if I was getting the right things, where it was like supposed to be a cat and stuff. I should try that one again and see what I can get. But if you get the right data set sorted out, and I don't know how the model numbering works, I think that's my problem, it seems pretty good. Seed actually point to one of their own open source projects where they've taken this very big other open source project and sort of converted it to suit their hardware better, and it appears that it trains multiple things at once in one dataset, I think, and thus you get multiple things appearing and you get nice captions about what it is, which sounds really good. Trouble is, I tried to get this running. I went through the instructions here, and some of them just didn't work. I sort of adapted it, and I managed to, run 10 hours worth of training, and I couldn't export the file to do anything with it. There is a lot of references to read. If you go to the original repository, it's absolutely huge, and there's worked examples there, but it doesn't really easily relate to what I'm trying to do. So there's stuff there. This could do with having a bit more of a tutorial about how to just run it through from end to end and have it working, because this looks pretty cool if that's what it does. But yeah, I didn't manage to get it working. I'm sure with enough reading and research and experimentation I could, but I just didn't have the time to do that.
Well, we're at the end of the video because it's become too long, and it's one of the videos that I'm not totally happy with because the scope of this is so enormous, it's got away with me. If we were dealing with things with like these sensors, like soil sensor, gas sensor, temperature sensor, that would be easy. We'd just, we'd put some code in, we'd do some stuff with this, we'd show how it worked. But the fact we're dealing with two things that make the scope enormous, one being the LoRa adapter, and that brings up the old loads of cloud services and how you get there and how you get the data across and back, and there's different ways of doing it for each, and most of which need a little JavaScript bit on the other side and all sorts of gubbins there. And then we've got this Groove AI vision sensor, which is a huge amount of stuff. It's quite interesting how it's done, but it's too much research, reading and development for the scope of this video. So I'll just talk about them briefly. As far as this thing goes, it was very interesting. We saw the different sort of data sets we had. So great success on the banana and the drone set once I worked out which was which. The cats were pretty bad, and I think that's interesting. You could totally go through and find lots of those images that I did on Google and basically train it yourself, which means putting it through a different piece of software, draw little boxes around them to say this is a cat, and feed them in much the same way. And once you built up several thousand images, you could be quite confident about it detecting cats. If it didn't work, then you could put more time into it. So there's something to be said for developing your own set, or making sure your data set you're going to use that someone else has prepared is very good. I felt banana's quite an easy one. I was quite impressed with the drone one though. That was picking up some sort of little tiny drones from all sorts of different angles from those pictures. It'd be quite interesting to see how it would work out in the wild. Obviously the speed of this thing, and I think they quoted it as taking about 700 milliseconds per image to do anything with, versus about 70 milliseconds if you're on like an i5 Intel processor. So it's not really something you'd attach to something and put in a drone and count sheep, as I suggested earlier, would be an interesting use case. Well, that would be interesting. But it's something you could certainly play with and experiment with and understand how things work. And I'd like to think you could do a bit more with it. For example, attaching it to something like this and a computer or something. I'd like to think you could set it up, have it point in your garden. You could detect, like, if a human came in your garden, you want to be alerted to that and you want to know about it. Or if you've got problem cats that keep appearing, maybe you want to know why those are there, and you could detect those. And that's where I feel we need a little bit more information about this, because how this works currently, if you want to get a picture out of it, obviously something like this or your debug stuff is basically giving you the text stuff. So it's basically saying, I have detected somebody, I'm 70% confident it's a human. but it's not pulling down the pictures. That's going to the computer. And right now, that only works by going to a website that is hosted by Seed, which runs some JavaScript, which talks directly to the USB and asks it to send it a video, or picture after picture is essentially what it's doing. Now, at the moment, that is only done via that website. So I'd like Seed to give out a bit more detail. USB wise, what you have to do is you connect to USB, you find the endpoint, and you basically send command protocols to the endpoint, and then it sends stuff back. We don't know what those commands are, so we don't know what you could do. So for example, you might want like a standalone Python application if you're offline, to basically grab the images at the time. Say it triggered something in your garden, you'd want to say, oh, grab that, and we'll look at that later. And you might want to grab it as the full 1600 by 1200 image. I don't know if that's possible or not, because we don't have access to any of the source with the firmware of this or how it works. So I'll be following that up with Seed about like how does this work, along with the fact that I had real problems despite my model naming about which was which. I named things 1, 2 and 3, and they basically worked as, yeah, I think they were pretty much 2, 3, 4. I don't know what happened to number 1 or why it was called that. I don't really understand how it works, and that's why I was slightly disappointed I couldn't get that other thing working, where it sort of drew the box and labelled it with a thing. That would be nice. So I'll be feeding back about this and like saying, you know, you need a better tutorial for that and this sort of thing. Overall, as a kit, I think it's very interesting if you want to mess around with stuff. I mean, I really like the YO terminal. I've looked at this before and I thought it was really cool. It's an Arduino compatible CPU with physical buttons that you can program. It's got a screen. Aside from the 2 Groove connectors, it's also got a Raspberry Pi compatible GPIO pins here, so you can connect a lot to that. That is a really nice little system for testing stuff on. And then you've got all the sensors. As said, you've got the sort of the more basic sensors. These are really easy to program. You basically just say read this data and it gives you a value, and then you can do with that what you like. And then you've got the slightly more complicated ones, the LoRa. It's going to depend where you are in the world about how well you can connect with stuff, but you can always do it via Wi-Fi. And of course the Groove module is interesting. You can also buy these separately. This is about $25, I think. It's not expensive. As a kit, I think it's very interesting. If you're interested in looking at this sort of stuff and prototyping ideas, then this might be something to check out. And in which case, check the links down below and then show you where to go. In the meantime, if I get some good updates about how to do certain things, I'll look into this a bit more, or if enough people are asking about how to do certain things, we can have another look at it. But for now, I think this video is long enough, so I bid you goodbye. I hope that's been interesting and or useful, and I will see you next video. Bye for now.
Well, you've made it to the end of the video, so thanks once again for watching. If you like what you saw, then please consider subscribing, and if you really like what you saw, then be sure to check out the link to my blog for a variety of ways in which you can help support this channel.